Dear colleagues, I am glad to present to you results of our research titled "A Method of Routing of Fractal-like Traffic with Prediction of Router Load for Reduce the Probability of Network Packet Loss" by Yelyzaveta, Meleshko, Hanna, Drieieva, Oleksandr, Drieiev, Mykola, Yakymenko, Mikhav, and Serhii, Shymko. The relevance of the research is determined by the constant growth of the load on modern computer networks. A scientific and practical task is development of a method for adaptive routing during high network traffic intensity in order to reduce the number of lost packets. Nowadays, mathematical models of self-similar time series are most often used for the mathematical description of network traffic. Therefore, fractal analysis and synthesis of network traffic was mainly used to solve the issues of scientific and practical. Here you can see the main message of adaptive routing at peak load and prediction based on traffic. Statistics such prediction methods as models of the subject area and time series models. Slide 3 shows the proposed mathematical model of fractal traffic, in particular the Markov chain for its generation and the proposed measure of fractal dimension. Due to the fact that traffic network is segmented by packets, it was decided to model binary traffic at the packet present, packet absent level. Formula 2 shows the dependence of the intensity of the traffic flow. Formula 1 shows the density of fractal flow of the accepted probabilities of saving the states of the generator. And Formula 2 shows the fractal dimension by introducing opposite assumes through probabilities lambda 1 and lambda 2. Here you can see the probability of loss in a traffic packet obtained on the basis of the proposed traffic model on the figure 1. You can see probability of Q overflow probability by 10 packets at different values of fractal dimension and input traffic intensity obtained as a result of numerical simulation. And figure 2 shows dependence of the sum of deviations on the exponent n. Exponent n is number in such a formula for probability of packet loss, p from d and tau. And by the mean squares, number n, as we found, is equal 0.99. Therefore, a traffic routing method was proposed, the stages of which are shown on slide 5. Stage 1 launch the OSPF routing protocol at 40% normal mode, but each router traffic split accumulated for a certain time interval t subscript n. Stage 2, based on the obtained traffic statistics for time t subscript n, the fractal dimension of traffic is calculated. The probability of packet loss PD tau is predicted in the future for each router. And at stage 3, the predicted packet loss probability is used as additional metric in SPF routing algorithm of OSPF protocol. We add the predicted probability of packet loss to the standard path length metric. Here the metric m subscript 2 equals to PD tau from formula, determined by formula 3 from previous slide. To test the proposed compared with other methods, the computer network simulation method was developed, the stages of which are shown on slide 6. The main stages are generation, of model on the basis of Albert model, checking for fully connectors, assigning weights to edges, generation target packets for transmission, and testing routing algorithms. Completion of the models works when at the some number of iterations, for example, 1,000 iterations, or when all queues are empty and all packets are either sent or lost. Next, here you can see some examples of computer network structure generated by our simulation model. Here we can see examples of generated fractal network traffic generated for experiments in this work. Traffic is represented by binary numerical series packet present, packet absent. Numerical series for quality in the diagrams were aggregated by 25 counts. Parameters here with different probabilities P0 and P0 here 0.05. You can see such results are typical for real compensating traffic of high intensity with tau equal 0.5. An experimental study of the forward routing method was conducted using the proposed computer network simulation model. The results of the study showed that the improved routing method allows for reducing the number of lost network packets during high traffic density, in particular at intensity of 1.0 to 3.8 times for persistent traffic, up to 2.7 times for random traffic, and up to 1.02 times with anti-persistent traffic. Average improvements values dependent on network parameters. And here you can see conclusions. A computer network model of computer network was developed to test traffic routing algorithms. A method based on the theory of complex networks was developed to generate the structure of the computer network, while Markov process and fractal time series were used to generate traffic. A method for routing fractal-like traffic with prediction of router congestion was also developed to reduce the probability of packet loss. And the results of experiments with proposed models showed that the first, under heavy network load, the least lost packets occurred with anti-persistent traffic, while the most lost packets occurred with random or persistent traffic. And the second proposed routing method significantly reduced packet loss under heavy network loads, with such numbers as you can see here. Thanks for your attention.